Hi guys, this is your embedded friend, and today we are going to talk about a DHT11, a temperature and humidity module, and we'll just try to understand how it works in general. So, it registers humidity and temperature by using a single wire communication. As you can see on the datasheet, it parses it in 40 bits, the total length of the communication to send humidity and temperature data. First 8 bits is humidity integer data, so whole numbers, and then next 8 bits are humidity decimal numbers, whichever goes after the point, like 0.1, 0.2, and so on. And then goes the temperature integer data, temperature decimal fractional data, and checksum so that on our side we could check that the data, all those first 8 bits are correct. And this is the whole cycle, but let's go into a small ones. So first, we as a host should let the sensor know that we want to acquire some data. The datasheet also says that it's not a really good thing to ask it more frequently than 2 seconds. So don't do that if you're going to write your own driver for this sensor. And basically we start the communication as follows: that we have I forgot to mention, we have the pull-up resistor on the single signal line, and this is done to basically maintain the signal line high, and it has 4 pins. The other 2 is V sub CC, your power that goes to the sensor, ground, and 1 is not used. Okay, and so we are driving the signal line low for more than 18 milliseconds, and then release it, and it goes back to high. And this is how the sensor knows that we want to acquire new data. And communication starts from the sensor side. Here it basically drives 80 nanoseconds low and then 80 nanoseconds high to let us know that it's going to start giving us some data. And as soon as those 2 cycles stop, goes the data. in this next step. And oh, this is how we are getting 80 bits of the whole data bundle. And how should we differentiate between the 0 or 1? Basically, it always starts with driving it low and then high. And the low part is always the same, it's 80 nanoseconds, and the high part is what differs. For the 0, it's smaller, it's, as you can see, 26 to 28 nanoseconds, and for 1, this is much longer, it's 70 nanoseconds. That's it, basically, simple as that. And we are getting all the data that we need, and just process the bits as I've said in the beginning here. So what library should we use for this one? If you take a look at the library manager in Arduino, and put in DHT11, let's take a look what we'll get. So you're not seeing here the like those are mostly hobbyists, and the one that I think is safe to use is from Adafruit. It's called Tiny DHT. You see that it's from Adafruit. I have it already installed, but I think you just can safely believe that it's okay, because we can trust Adafruit, who are the guys that make even their own boards and stuff, so I think it's safe to really trust them. So install it for yourself, and let's have a look at the GitHub page. So let's start from the header file. Basically, it's made not only for DHT11, but some other alternatives, and you're just choosing what's needed for you, which we'll do later. And so you initialize it using the constructor, passing the bean type and count. They say that count is used to set how much data to take at a time. Very few reasons to change this, so we won't do that. You just start it with a begin, and use functions like read temperature to read temperature, and read humidity to read humidity. and this one is to convert degrees to Fahrenheit, but you're not going to use it. There is no reason. You just say what scale you want, Fahrenheit or Celsius, when you call the read temperature function. And let's look at the source files. We won't look at the helper functions, the main one functions. We'll look at the read, because that's, I think, the most interesting part. So they pull the pin high, just a precautionary measure. But we need, let's take a look. We should check. We need to pull to go low to start the communication. They are of course working with the time to check how much time was the low cycle, high cycle. They are checking precautiously that the last read was not like less than 2 seconds ago. As I said, it's also written in the datasheet, so that's totally what we want. And here they start the clock, let's say, zeroing out every data, because I think that's the global thing, member variable. And then pull it low for 20 milliseconds just to be sure, because the datasheet says more than 18, so let's not put 18 here. And they disable interrupts, just to be sure that during the reading procedure we are not interrupted. Simply saying, because of course there can come interrupt, and then the sensor is still going and you are just losing lots of data, and when we are returning from the interrupt, we are trying to read, and maybe even a sensor has already finished, so we are waiting for some signals that should not occur. Okay, and this one is just precautionary, that it's driving the pin high for 40 microseconds, and then the main cycle begins. We are trying reading all 40 bits of information. Here you can see that they are ignoring the first 3 transactions. What are the first 3 transactions? Basically, the first 2 are those 80 microseconds low and 80 microseconds high from the sensor. The first signals that we are getting that are saying that, okay, I'm sending you the data, be prepared. And they just decided to ignore it, but of course in a more professional code base when you're not working with the Arduino. You won't be ignoring anything. You'll be reading and checking that it's indeed a confirmation from the sensor that it's starting to give us the data. And the third transaction is basically the first low microseconds, and basically they're always ignoring the lows, because the significance goes in the highs, which differentiate for us if we are getting 0 or 1, and they are filling up all data bits, and after everything, because this is basically uint8, I assume, which has 8 bits and in the end they enable back the interrupt because all data are red, and we are checking that we got all 40 bits first of all, which is important, and that the checksum is right. And that's basically it. Nothing complicated about it. So let's use this and try and write our own small program. Let's include tiny DHT. Hope it's right. Yes. Okay. DHT. Let's call it DHT11, and we need pin and type. I've connected mine to digital pin 8, so this will be 8, and type, let me just return to header file. We don't need this source file noise. I think that's the one. Okay, and setup. Let's create a serial to just see what information we are getting, and start the DHT in the loop, as simple as that. Okay, so humidity is uint8 and temperature is int16. Okay. Humidity DHT. Read humidity and int 16t temperature. I forgot that I've called it DHT11. Let's just remove 11. Read. And let's take a look. It's false by default and false in Celsius, and I'm in the Celsius part of the world, so let's leave it at like that. Let me just for the sake of beautiful code, and we just need to, I think, let's have a check. That we are not getting any invalid data. I think we can check this by this: bad temperature, bad humidity, bad temp, bad this can really help you if you set your sensor like messed up some communication, like just connected it wrong, so you'll get the message and not interpret something wrongly. I'm not sure what would be if you try to output. I think you'll just get gibberish data. Okay, and else print temperature. Okay. Okay, and then temperature, then we want I think that's how it's written. Let's use it like that, and humidity. Print, yes, finishing the line, percent, because humidity is 7%. And I think that's it. So as simple as that. We'll remove this and this. This is not necessary. And I have connected the thing already. Here's the sensor, and if you look at the datasheet, it has 4 pins, which is right. That's how it goes. But I have like soldered it to a little board, and I have only 3 pins for myself to use. And to be honest with you, I kind of struggled at first because it's not clear which is a signal, pin, ground, and VSubCC. So if you have something similar, just look here. S means signal, and here's where the signal line, the data line we have. In the middle we have VSubCC, and the other one is ground. You can differentiate between colors. I think it's pretty clear in my case. And then we have here that goes the data line, and I have also the 10K pull-up resistor here to have the line high, and then it also goes to pin 8 on my Arduino Uno. I have small capacitors to regulate the power in the power rails here, and this one goes to the sensor, and here I've connected ground of Arduino to ground on the breadboard, and 5-volt supply on Arduino to here, the positive rail. That's basically it, and let's try and load our program up on Arduino. You know what, I think we're missing a delay. It's not overpowered. You know that we don't need to read information very often. Okay, let's load it up. Let's open the serial monitor, and we have already some success. So 21 degrees Celsius, humidity is at 54%. I don't know if that's good or not. It's pretty chilly a bit, but okay, that's pretty much it. As you can see, it's not really hard to type this kind of stuff. When you're using the library, you don't even have to know what is going on, You just have to know how to properly connect everything, and that's it. But I think it's crucial to understand what's going behind the sensor, because at some point in your professional career, I think you'll need to maybe write a driver for a sensor for your particular board, which has some different, like, very specific things going on. And yeah, this is really the hobbyist thing, and is very there is a lot of this on the market, but you can come up with something which is really not. And maybe there isn't anything written for this type of thing. So yeah, we just need to understand how to read the data sheet, and then how to reinterpret the data sheet into the source code, and then interpret signals into the real data. So I hope this was useful for you. If you have any questions, write in the comments. I'll be happy to answer them. You'll have this source code in the link in the description on my GitHub, so you're free to download it and try it yourself. But I think you can easily write it yourself. It's not really complicated. Maybe if you're up to it, you can write your own driver, your own library for the sensor. It doesn't have to be perfect, but still you'll learn something. So yeah, I hope you enjoyed and learned something, and I see you later. Bye.